Hello YouTube, it's me, Solomon Kuruma again. Today I try to explain how we control temperature, pressure and level by using TIA Porter version 12, which I wrote this project quite recently, which I want to post. So if I open some of my project, I open. Okay. Then I open the project. Open the project view. So basically I used CPU 317.2 PNDP incorporate with KTP 1000 basic colored PN. Okay, so the controller is S7300 and the HMI is TIA Porter, and the program is being written in TIA Porter. So if I open this CPU, then I open the project, the program blocks where I wrote the programs. So this is basically my scaling, my analog scaling. My RAM is a little bit slower. Okay. So these are some of my scaling. I wrote some of my variables for my scaling, and this is for the valve. Okay, to open valve manually and automatically, and this is the safety. Okay, this is the analog data block wherein I put all my set points, variables and set points, and these are the HMI buttons. So I created a tag which I call solo tags. This is my tags, all my tags I'll be using throughout the project. And if we come to the device configuration, you will see the IP addresses on the hardware configuration. This is the CPU I use, and these are some of the input and output. So if you go to the network view, so you can get your IP addresses. This is the IP address for the PLC, and this is the IP address for the HMI. Okay, so if we come to device view, you can see some of our analog, the analog input. We want to know the values. This is my analog input address. Start from 304 to 311. That is the analog input. So basically, if we open the scaling block FC2, this is where I did, this is for the temperature transmitter. This is for the pressure transmitter. This is for the level transmitter, and this is to open the steam valve. can see I design it. Solotech valve block. This is to open my steam valve. Okay. Then let us simulate this project and see if it can work. Because I wrote this program a long while ago. So this is my HMI. You open the HMI, the main screen. Let's close some of these variables so that we can see the screen very well. So this is the screen. Basically, it's just, I was trying to build it up, but I just want to explain how we do the level, the temperature, the level, the pressure, and the opening of the valve, steam valve. So let us see if this project can work. Let us simulate. Okay, let's go to PLC. Program blocks, open one data block. Let us simulate this project. Simulate. Yes, I want to simulate. This is my PLC. Okay, I reset. Memory reset, yes. Then I try to download the project. Download the project. I select my interface. I'm going to use the type of PC interface. I want to use PN. And what kind of PG interface I'm using? I'm using simulator. Let's see if we can load. The connection of subnet is PN1. It's reading. Now we are online. You can see. Then I can load the project. Then I have to load all the blocks for us to simulate this project. I have to load all the blocks in the PLC. Then I open my simulator, then I go to run P. Let's see if we can run. Okay, we are good to go. So we open the HMI, this one. We simulate this one too. It's doing compilation. Okay, it has compiled everything. Now we start the simulation. So this is the basic screen we have presently. So if we open our simulator now, so this is what we'll do. Now we want to run the, let's say for example, the temperature here. Presently, if you can see, this area is 0.0 degrees. So let's see how we can run this temperature, if we can achieve it. Okay, so let's go to the temperature blocks. That is FC2, where I did the scaling. Let's go online and see what happened. It's compiling, take a little while. Okay, now we are online. So you can see this is the analog scale output, which is 0.0. So, and this is the peripheral input word, IW288. So, but if we can come to our device view, or device configuration, analog, we right click, properties, analog input. You can see the analog input here. The address starts from 288 to 30 to 303. So the peripheral input word for the temperature is BIW or IW288. So if I can input IW288, if I can input this one to the simulator, for example, input IW288, which is the peripheral input word. Let's go to slider, device slider. So my minimum is 0 and my maximum, my analog scale 27648. It's my maximum temperature. So let us simulate. Let's see what we will get. So now, if we take a closer look at this point, TB5, TBD 0, if I slide my this way, if I slide this one, we notice there are changes in the temperature. That is, we are doing our scaling. So if I try to slide, you can see it's changing to the last scale that will give us 100 degrees. Okay, and this is the analog scale, standard scale. So if we can go to our simulator again, and we have our, let's take a look at this area. If I simulate, you see the temperature is changing. Bring it like this. Just watch. Here it's been truncated, it's rounding up the value. This is 3.9, on the HMI is 4. So you watch the HMI, you watch the HMI. So see the temperature is changing, it's reading. The temperature is reading as far as 100 degrees. So if I slide again, go to 0. Okay, so that is how we control the temperature in TIA Portal version 12. So this is the block I designed. So if we come to the valve, this is the steam valve. Now it's open 100%. Why is it open 100%? We need to check. So if I open the simulator, if I click on the valve, we get a small dialog box. So now what I'm trying to say, I have to do a set point for this valve. There is no set point. That means at this particular set point, you have to execute something. Let me say at 50. That's my set point. And this is my gain. Let me do my gain to 0.1. That is how fast my valve can open. Then let's see what happens. Let's simulate again. Now at 50, let's see what will happen to this valve. And you watch the red bar, and this is the set point. I set 50 degrees. When this temperature is at 50 degrees, do something. So I try to regulate my temperature. You take a look at this temperature. When this temperature is exactly 50 degrees, because that is how I set my valve. you observe the valve is shutting down gradually because it has exceeded my set point. The valve is closing. You can observe here gradually, but how slow my valve closes is depend on my gain. So I set my gain to 0.1, so the valve is gradually closing. Okay, if I set my gain to, let me say, 0.5, it becomes very more faster, closes more faster. You can see it's why the valve is closing, because my temperature has exceeded the set point 50 degrees, so the valve is shutting down gradually. Yeah, and 0. So what happens when my temperature now go below 50? The valve will open. So if I reduce this temperature below 50, what happens? The valve start to open. Okay, so these are some of the basic things we're supposed to know as automation. Now the valve has opened 100%. Okay, now if we come to the level, for example, if we go to the level, temperature, pressure, level, our peripheral input word for level is 292. So if I input 292 in my simulator, PIW 292, my slider, minimum value, maximum value 27648, and I try to slide. You see some changes here. Okay, so if I open the HMI, this is my peripheral input word 292. That is my pressure transmitter is within this tank. So let's simulate. So this is what is happening. So now I'm simulating my liquid, whatever liquid is inside is 46 liters. I don't know. It's just to test. Okay. Okay. Yeah, 250 liters. So there's it. So simulated for level. We can take it back. Take it back. Okay, last but not the least, let's simulate for pressure. So if we come to pressure, our pressure scale from 0 to 5 bar, and the peripheral input word is 290. So we input 290. PIW 290. Sorry. Two 7648. That is our pressure. 290. Then you notice, you see what is happening. So if we open the simulator again, let's watch the pressure. It has 0.2 bar. If I take it, start to slide, you can see the pressure is changing. 1.3 bar, 1.2 bar, 1.6 bar, 2.2, 2.5. The last scale limit is 5 bar. 5 bar. Then I take back. You can see how the pressure is changing as I'm sliding my value. So far you get your scaling right. My value. Okay. So that is all. YouTube, thank you for watching. If you are interested, you can call me. My address is down there. My email is there. I hope you learned something. Thank you.